The next parts that we're going to work on are the bearing blocks that support most of the parts in the helicopter, but they also hold the ball bearings. There are quite a few of them. As you can see, they run between the two sides of the helicopter, and these holes here where I have shafts running through, I haven't drawn in the bearings, but there are ball bearings that go in all of these blocks. So there's one here and here and here and here, and this one doesn't have a ball bearing, but it's there. And then this one, the main transmission block, has ball bearings on either side, and then in this little enclosure is a thrust bearing that the pulley sits on. So we're going to be making all of those parts. All right, I've cut up a bunch of pieces from bar stock that are going to be used for the well, they're the spacers between the sides, the two sides of the helicopter, but they also support all of the parts within the helicopter. They have all sorts of holes drilled in them. They're the bearing supports, and well, they serve a zillion different purposes. Each one is different too, but they all have. I mean, they all have to be the same width because they're all sitting between the the two side pieces. So that's the first thing I'm doing, and I've just put four of them in the vise here and fly cut the top. So now what I'm going to do is just flip them over, but first I'm going to measure one of them. So they all start out at the same length, and I'm getting a reading of 0.991 smidgen. So I haven't moved the fly cutter. It's at the Z position I just left off at. So I'm going to now set my DRO to that measurement. So now when I flip them all over, I'll be able to just go from that DRO position down to the final height of these pieces. At least that's the plan. I do this differently every time I fly cut. I'm always looking for a new and improved solution to figuring out how to get all these things to the same size. All right. All right, the plans call for these all to be 0.984 of an inch wide. And we're at 0.992, so we don't have a whole lot to remove here. And the thing is, as long as they're all the same width, it really doesn't matter. If the helicopter's a thousandth of an inch wider or not. But we'll try to get it right anyway, just for fun. So I'm just removing 4 thousandths. just going to come back, take off another 4 thousandths, and that should be the final dimension. When I was looking at the video last night, I realized that the way the light was hitting the fly cutting, it made it look like it was only fly cutting half the part, and that the half on the back of the jaw wasn't being fly cut. That was just an illusion from the way the light was hitting it. I mean, I was getting a very nice fly cut finish. I'm just checking that, just a sanity check that they're all the same. It sounds silly, but I do lots of sanity checks. And they are. So, and those are all the same width. What I'll probably do now, like I said, all of the blocks, I mean, some of them are different dimensions, but they all have to be the same width. So I think what I'm going to do now is just work on two of the other blocks. These are wider than the first two, than the first group. They still have to be that same width, so. So I'll just do that. I'm just checking my X limits. Right. So I can just flip them over now. Back. And I know the DRO is okay. I just measured just to be sure, but the DRO is okay because why wouldn't it be? the measurement we set when we did the first group. So I'm just going to do the same thing. I'm going to move 4 thousandths in the pass. Right. I know this is extremely tedious, and both for you watching it and for me actually doing it, but I just wanted to get you started on seeing how I go about this. I'm just going to check this because a lot of times when I'm talking to the camera, lose track of what I'm doing. So. Well, anyway, I don't know how much more of this you need to see because it's incredibly boring. But I'm just going to keep, putting the parts back in, flipping them to a fresh side, cutting one side, measuring, flipping it over, and cutting the other side until I've done, all the sides on all the parts. And I just can't see any reason why anyone would want to watch this. So. I'm going to let you pass, and I'll bring it back when there's something more interesting going on. Well, several hours have gone by, at least, but I've got all of these blocks, machined down to their final dimensions. Same process I used that I just showed you. It's just very repetitive and time consuming, but anyway, that's done. Now, each of these blocks needs, essentially holes drilled in them. Some of them are drilled and tapped, others are drilled and reamed, and I think every single block is different. They're very similar, but different. So what I've done is I've indicated off the back jaw on the side of the jaw here to find a 0 point. so I can line up a piece for an operation. So if you saw what I just did, your fingers, or biological calipers as I like to call them, have the ability to perceive whether something is completely lined up, to much better than 1/1000th of an inch of accuracy. So what I'm doing is I'm just lining each part up, right at the edge of the jaw. And then what I'm going to do, this would require, center drilling, and then tapping. And to line up a piece and make 3 tool changes just seems to be way too much work. So what I'm going to do is, I've got the center drill in here. I'm going to line each piece up and center drill it. And we'll switch over to the regular drill and do the same thing, and then we'll switch over to the tap and do the same thing. So that's my plan of approach. I'm just set up to center drill. Which is no big deal. Now I'm just going to, in this case, these parts have to be drilled from both sides. So I'm just going to flip the part over. Line it up. Repeat the operation. My gut just tells me that this way of doing it, without doing all the intermediate tool changes, is just faster. So, one by one, I'll go through these and do all the center drilling. I'll come back in a few minutes, and we'll do the drilling exactly the same way. Okay, all of the blocks have now been center drilled, and it's amazing how much easier it is to do this once you've done a couple of them, to get the alignment right. It actually moves along very quickly, and for purposes of these parts, it's at least as accurate as we need. So I'm glad I'm doing it this way because it's saving a ton of time. And now what I'm going to do, is sorry, let's just make sure that was exactly right. It was, but now what I'm going to do is is drill these for the next step, which is tapping them. These are all going to be taking M3 screws. This is really the mechanism that holds the whole helicopter together. These are essentially the cross pieces between the sides. Everything connects to everything. I'm just moving over to where the second hole is on this one. Drilling that. Just going to flip the part over. Like that. Drill again. I think you can see what I mean, that this is much faster than, have we been doing tool changes in between each of these operations. Now if we had an automatic tool changer, that would be a whole different story. But we don't. Alright, I've completed drilling all the holes into all the parts. Altogether, it took 15 or 20 minutes because there are quite a few of them, as you've seen. And the next step is to tap these holes. My tap wrench came with this adapter that slips over the end of the tap wrench, and it's used for keeping the tap wrench at true vertical. So I just I have it in an end mill holder, and I screw it into my spindle. Slip the tap wrench in, like so. A bit of tapping fluid. Tap the hole. Bottoms out. And I just have to flip the part over to the other side. And then repeat that for all the parts. Alright, all of the end holes have been drilled and tapped. So now a bunch of these parts need a 1/4 inch hole drilled and reamed through the center of them, and that's what's going to support the ball bearings that keep everything running nicely. So Again, I'm just lining it up with the edge of the jaw here. That's right on. Now, unfortunately, the piece isn't wide enough for me to leave the parallel in here because the drill will hit it. So I'm going to have to take that out and just rely on the clamping force of the vise. But for drilling, that ought to be fine. Before I did, each operation before doing the tool change, but because this is just 3 operations all with the same tool, the drill chuck, I'll just replace the bit and I'll do all 3 operations on a part before I switch to the next part. So the first step I'm going to do is the center drilling. And what I like to do when I'm reaming a hole is to choose a drill bit that's between 10 and 15 thousandths less in diameter than the reamer, so that the reamer actually has some material to remove. The last thing I do, I just take a countersink and just between my fingers, I just, twist it a couple of times, and that just takes any burrs off both sides of the hole. I find it to work very nicely. It's very simple to do. Alright, so that part's done. And I have, lots of other parts. They all need this, this 1/4-inch hole drilled in them. Some of them are bigger and smaller and whatever, but it's all basically the same operation. So I'll go ahead and and complete all that before I get back to you. I've been working on the transmission block that sits on the top front of the helicopter, and it takes the rotational energy that's coming up from the flywheel and from the pulley that sits down on top of this. And what I'm about to do now is just to put a decorative round boss on the front of this. We did something similar with the cylinder block in the beginning of the video series. The difference now is that I treated myself to a four-jaw self-centering chuck. If you remember, before I was using an independent chuck, and part of the issue was figuring out how to get a square piece of stock centered. But now it should just be a matter of placing it in the chuck and letting the chuck do the work. Because nothing is ever as easy as it could be, we have to put a spacer in here, and I'm just using a parallel to give us enough stock clear of the jaws to work on. I think that's all there is to it. And no, of course, I've never done this before. Just got the chuck. And now, of course, you have to take the spacer out, or else physics will take it out for you when you turn it on. So. Anyway, that should be perfectly centered now. So. Alright, the first thing we want to do, as we always do, is find the Z. So I'm going to jog in this way. It's right there. I'll set that as Z0. While I'm at it, I'm just going to take a very light skin cut, facing cut. Wasn't enough. And that's still not enough, but we're very close. That's good. Now, I'm going to reset that to Z0. And we want to He was just making sure we had enough sticking out, which we do. So now, I'm just picking up approximately the side of the part here. Just to get a rough idea of where we are. I'll just set my DRO to match that. I know that's not exact, but it doesn't have to be, because we'll do some cutting, then we'll come back and measure. Okay. So now I have the numbers I need to set up my wizard. The next thing we're going to work on is the tail rotor gear holder. It's a block of aluminum, of brass that's cut, into this U shape, and there are bearing holes both here, and another one in here. Let's get a better look at that. So we have bearing holes here, and another one down in here. This is made from a solid piece that has to be machined out and rounded over, and obviously squared up and made to size. So let's get to work on this. I'm working on the gearbox for the tail rotor, and I've been obsessing over this part for a couple of days, trying to figure out what order to do the operations in. I showed you the CAD drawing, and it's essentially a U shape, so this black area here has to be cut out with the bandsaw before I mill it, to make it square. So I've drilled a couple of holes in here just to help with the bandsaw. And also there are ball bearings that come in from either side, and then another one from the back, because there are two gears here meeting at 90 degrees. So what I've been obsessing over is what order to do things in. I mean, the drilling of the holes was pretty obvious, but if I cut out the centerpiece here, then there's, I have to round, profile, rounded corner on the end of the part. And what I was afraid of is if I milled out the inner piece first, there just wouldn't be a whole lot of stock here to take the force of the end mill going around it. So what I've decided to do is do the rounding operation first, and when that's done, just cut out the inner piece. I've done a little bit of rounding, just on my sanding machine, but the end mill is going to do most of the work. So what I'm going to do is mount it in the vise with enough stock sticking out so that the end mill can come in here and do its job. And I'm only going to go a little more than the thickness of what will be left after we cut out the middle piece, so I'm going to have to then flip the part over and do the other side. So for that reason, I'm going to have to find the edge of this part, for X, and then we'll have to do it again when we flip it over. I doubt I can get it back in the same spot. I'll just sneak in on it. Okay. Now I know where X0 is. I already knew where Y was because I've indicated off this back jaw. Find Z0. Alright. That was easy. Now I'm going to flip the part over, find X again, and do the other side. Now what I'm going to do is head over to the bandsaw and cut out this, this middle part. Then we'll come back here and just use the unmill and clean it up. All right, I've hacked out the center part here, and I used my edge finder to figure out, where the part begins, and I did some calculations to figure out how far the bit has to come over to this side to get the right thickness here, and how far it has to move to that side. And I've also got the bit now set at what will be the bottom of the part. So now it's just a matter of using MDI, which is manual data input, where I'm just entering simple G codes like, G1, out to here, which is 0, and then a G1 back. There's nothing overly complicated about this. So now what I'm going to do is move over a little bit. And come across at a feed rate of 5. And I've just moved over a little bit more. And I'll go back. I'll just keep doing that until I get to the point I calculated, which was the far extent here. All right, well that's where I'm supposed to stop. So I'm going to stop now and then start working from the other side. All right, I've completed this side of the part. And now I'm going to do the same thing. I'm just going to work my way over to the other side. Figure out where to start here. Looks good enough. And there we are. One tail rotor gearbox. It's going to need some sanding and stuff, but it's done. It's got the slots for the 4-ball bearings and room for the gears in here, and well, that was the deal. So